Hello there, random smart person on the internet. A few weeks ago, I had the privilege of being invited to Mrs. Yaklick's 5th grade class at Anderson Creek Academy in North Carolina. Her class watched my videos throughout the school year and prepared some pretty interesting questions. I wanted to share these thought-provoking questions with you. Maybe you too can learn something from these curious kids' cosmic queries. And if you're a teacher or know a teacher, stay tuned to the end of the video for a unique opportunity for your class. The first question is, do you have a telescope that can see Jupiter's storms? Yes, I actually have two telescopes. I have a 16-inch telescope and an 8-inch telescope. Now these inches, they are the diameter of the telescope, so it's the size of the mirrors in it. So the 16-inch telescope is about 6.5 feet tall, 16 inches in diameter, and weighs 277 pounds. It's also a go-to telescope, so I can type in whatever I want to look at and it goes right to it. The 8-inch telescope is obviously much smaller. It's only 8 inches in diameter, about 4 feet tall, and it is not go-to. But my kids absolutely love it because I can just take it outside, plop it down. We look at the stars, other planets, storms on Jupiter, and it's just so easy to use compared to the 16-inch telescope where I have to basically take it apart to move it. But you can absolutely see the storms of Jupiter with just a small 8-inch telescope. And it's really cool. Why do stars appear to twinkle? Stars appear to twinkle due to something called atmospheric scintillation. This is due to turbulence in Earth's atmosphere. So as the starlight enters Earth's atmosphere, it actually moves, and by the time it hits your eyeball, it is jumping back and forth, so it appears to twinkle in your eye. So the reason stars appear to twinkle and planets don't is because even though the stars are much more massive than the planets, they are so much further away. So light appears as pinpricks, and as it enters our atmosphere, it jumps around, and it jumps around to our eye, where planets, their light, since it's much closer, the light is so much thicker as it enters the atmosphere, it isn't affected as much by the atmospheric scintillation and the turbulence of the atmosphere, so it doesn't appear to jump around in our eyes. What is the biggest star? The current title holder of the largest star in the universe is Stephenson 218. This star has a radius of 930 million miles. For comparison, our sun only has a radius of 433,000 miles. And if you were thinking UI Scooty was the correct answer, that star only has a radius of 738 million miles. Stephenson 218 is 2,150 times the size of the sun. It is nearly 20,000 light years away from us. If you were to take it and put it into our solar system, that star would engulf the orbits of Mercury, Venus, Earth, Mars, Jupiter, and Saturn. It is huge. What is the oldest star ever discovered? The Methuselah star is located in the constellation Libra, about 190 light years away from Earth. This star is in between 13.2 to 13.6 billion years old. Since the universe itself is 13.77 billion years old, this star formed relatively quickly after the beginning of the universe. What is the biggest black hole? The biggest black hole is Phoenix A. This black hole is 24,100 times the mass of the black hole at the center of our galaxy. Sagittarius A star, the black hole at the center of our Milky Way galaxy, has a mass of 4 million of our suns. This means that Phoenix A has a mass of nearly 100 billion solar masses. I mean, take a look at this image. This is Phoenix A compared to the previous record holder of the largest black hole in the universe, Ton 618, and how it compares to the orbit of Neptune. We are just specks compared to this black hole. Is a black hole heavy? They are very heavy and very dense. Stellar black holes are about 3 to 10 times the mass of the sun, while supermassive black holes at the center of galaxies are millions and billions of times the mass of our sun. Our star doesn't have enough mass to become a black hole, so you don't need to worry about that. Is it possible for a black hole to swallow a galaxy? Even though black holes are big, and they are not big enough to swallow an entire galaxy because galaxies are much, much bigger than the largest black hole. How do black holes slow down time? And in space, does time pass faster, slower, or normal? To answer this, we look at Einstein's theories of general and special relativity. In science, theory does not mean guess. A scientific theory is an explanation of an aspect of the natural world and universe that has been repeatedly tested and corroborated in accordance with the scientific method, using accepted protocols of observation, measurement, and evaluation of results. Established scientific theories have withstood rigorous scrutiny. Now, the two theories we're going to have to look at are general and special relativity. General theory of relativity says that gravity slows time down. So the less gravity there is, the faster time occurs for you. However, special relativity says that speed slows time down. So as you travel faster, time actually slows down for you. There are practical uses that we use every day that use these two theories. GPS satellites must take into account both special and general theories of relativity to work. Since the satellites are further away from Earth than we are, they experience less gravity. So, according to general theory of relativity, their perception of time moves faster than us. However, because they are traveling faster than we are, according to special relativity, time moves slower for them. When we combine these two errors, we determine that satellites are actually tick 38,640 nanoseconds faster per day than we experience here on Earth. This amount is very, very small, but it's large enough to where if scientists didn't take into account these two theories, GPS satellites would be useless. How long can you survive on a spaceship? Surviving on a spaceship really depends on how much food and water you have and how much radiation you're exposed to. People have lived on the International Space Station for over a year, so you can live on a space station for more than a year, which can get you to Mars. However, one of the things we have to take into account while traveling to Mars is the radiation you'll be exposed to. For astronauts on the International Space Station, they're still protected by Earth's magnetosphere, where once we travel to Mars, we won't be protected by Earth's magnetosphere and we'll be exposed to cosmic radiation and solar radiation. So that's one of the things NASA and other space agencies are trying to figure out to send people to Mars. What made me like space and when did I find interest in it? I found interest in it when I first saw Star Wars, probably when I was 4 or 5 years old. That just made me absolutely fall in love with space, just thinking about how people are flying around in spaceships and you have the Galactic Empire fighting the Rebellion, which the Galactic Empire is actually the good guys of the story, and that's the hill I'm dying on. So Galactic Empire, good, Rebels, bad. I said it. I said what I said. Was there a scientist that made me want to make a YouTube channel? Yes, actually it's Dr. Phil Plait from Crash Course Astronomy. I remember watching his videos that he put out weekly on Crash Course series, and I absolutely loved it, and I wanted to spread my joy of discovery to everyone just like he did, so I really look up to him. And Crash Course, if you need another host, I'm your guy. Why did I make my YouTube channel and what inspires me to post videos on certain subjects? I love spreading the joy of discovery to everyone, and that's why I made my channel, to spread my love of science and math to everyone. And I post videos that are interesting to me, and I just love the topics, so I want to spread that love to everyone, to you. Do I have any pets? And if so, can I include them in one of my videos? Yes, I have 2 dogs and 2 cats. My 2 dogs' names are Nymeria and Bear, and our 2 cats, officially one is named Umbreon, but we just call it Kitty, and the other one is Milo. And now for a bonus question from one of my viewers. See, I told you I would answer those questions in the comments section. Comments are good for the YouTube algorithm. Michael asks, why does the moon look bigger when it is closer to the horizon? And why does the sky change colors at sunset? So the moon is not actually larger when it is closer to the horizon. Your brain just thinks it's larger because it is used to seeing things on the horizon as actually really close. So whenever it sees the moon on the horizon, it makes your brain think that it's really close. You can actually test this. When the moon is on the horizon, take your hands and see how big the moon is. And then a few hours later, when the moon is higher up in the sky, put out your fingers and it's the same exact diameter. So it's actually just an optical illusion and it's not actually bigger. And as far as different colors at sunset, during sunset or sunrise, when the sun is closer to the horizon, the light must pass through more of the atmosphere than it does when the sun is overhead. This means there's more scattering of light, including longer wavelengths such as yellow, orange, and red, which creates the different colors at sunset and sunrise. So there you have it. You learned about the curious cosmic queries from Mrs. Yaklick's 5th grade class. If you are a teacher or know a teacher, Fun with STEM wants to partner with you. Kids are, by their nature, curious about life, the world, and the universe. They want to know about things like, why do things fall? How do planes fly? What are stars made of? And what do dinosaurs eat for breakfast? And so much more. They have all sorts of questions, and I want to help you answer them. Teachers, if you want me to make a video answering your kids' scientific questions, send me an email from your school's email address to the address that's in the description with your name, the school you teach at, your student's grade, and all of your students' STEM-related questions. I will take those questions and make a video in a new series I'm calling STEM Queries. I will give you, your class, and your school a shout out in these videos. I look forward to answering all of your kids' questions. And always remember, have fun with STEM.